Hello, Grade 9 Science. Welcome to day number 2, distance learning, this Tuesday, March 24th. I hope you had a good first day and I hope today is going well. Today in this video, I'm just going to go over the Monday morning warm-up answer. I know some people are curious to see what that was. Nobody got it right, actually, which is interesting. It makes me feel pretty good, I guess. A little tricky. But then after that, I'm just going to do some notes on acceleration. So let me first get to this warm-up drawing, and this was kind of what it was, something like this. Let me draw on my hidden parts. Maybe you could start to see this one might give it away. I was supposed to be the stick figure man doing a push-up. So stick figure doing a push-up with apparently really long arms. But that was the Monday morning warm-up, so a person doing a push-up. In terms of today, I want to expand upon what we talked about with speed a little bit. So speed is how far you travel, your distance divided by time. We're talking about motion, getting ready to talk about the types of energy, and one of those being kinetic energy, and that's based on motion. But I wanted to talk about acceleration today. I have my notes page, but today is March 24th, 2020, and we're just going to do some acceleration basics, and then I'll do one more topic down here. So there's two left-hand topics for the day. The first one is, what is acceleration? Acceleration is any change in velocity. Any change in velocity. And velocity is really speed with direction. So anytime you change your speed, you speed up or you slow down, that's called an acceleration. And even if you stay at the same speed but you change your direction, that's an acceleration as well. So there's three ways to accelerate. You can speed up, you can slow down, or you can change direction. You can do like a combination of two of those three: speed up and change direction. But that's what acceleration is. It measures how quickly we change our velocity. I want to give two examples. So the first one is going to be a constant velocity, constant velo, and imagine a car, and it's moving along at 50 miles per hour. And if it just stays steady at that rate, car, I'll do it 3 times. I'll get the right whooshing lines, same number, it's going to stay the same, 50 miles per hour. And then one more, 50 miles per hour. This is what we will call constant velocity. I won't use velo, velocity. But that's something that's staying the same. And if we look at an acceleration is a little bit different. What an acceleration is, imagine we had an object and it's moving 0 miles per hour, and then it starts moving a little faster. It goes 10 miles per hour, and then it speeds up a little bit more. So then it's going 20 miles per hour, and then it speeds up a little bit more. And if you notice in my just simple drawing, more whooshing lines means it's going faster. It's going from 10 to 20 to 30. So this will be our last velocity here. I'm trying to make the distances bigger between the objects because it's going faster, it could cover more ground. But what the acceleration really is, it's not the instantaneous speed at any moment. What the acceleration describes is how it's changing, how the object is changing its speed as it goes. So the acceleration here would be 10 miles per hour per second. And it's kind of a weird unit, but that's the way that acceleration is described. And what this means, 10 miles per hour per second, is it means for every second that goes by, this object will gain 10 miles per hour. So if another second were to go by, way out here, it would be moving, I ran out of room, but it would be moving at 40 miles per hour, then 50 miles per hour, and 60 miles per hour. And we can actually have what's called a negative acceleration or a deceleration. And that would be, imagine an object moving at 40 miles per hour, and then it goes down to 30 miles per hour. And we get some whooshing lines to indicate motion. And then maybe to 20 miles per hour. Here, the acceleration would be negative 10 miles per hour per second. That means it loses 10 miles per hour for every second that goes by. So those are examples of acceleration. For the next left-hand topic, the final one, we're just going to talk about calculating acceleration. So to calculate acceleration, it's pretty simple. Acceleration is change in velocity divided by time. So this delta symbol, this triangle, means a change. It means some value has changed from one thing to another, and divided by time. We can also write final velocity minus initial velocity divided by time. And those are different ways to calculate acceleration. And in terms of the units for acceleration, there's a bunch of different units. The one I did above was miles per hour per second, or you can do something called meters per second, because the units of velocity can be meters per second, and then you divide by seconds. And this is a simple way to calculate acceleration. So you can try to use these ideas and see if you can answer the homework questions. You can try them and hopefully come up with some of the answers. If you have some confusion, feel free to reach out and contact me. These are brief videos, not like as many examples as what we would do in class. But the most important part of this distance learning right now is just to communicate with me, make sure that I know if you have issues or if you need help with something. I try to stay on my email and classroom all day so I can respond to you. And I hope that this is a good start for learning about acceleration and a little bit of motion. And I hope you have a good day number 2 of distance learning. All right, thanks.